Welcome back to Daily LeetCode. Daily LeetCode. This is day 69. We are back once again. Yesterday was a shorter session, right? Yesterday's video was also called No Days Off 2, No Way Home. Today's video is going to be called No Days Off 3, Homecoming. So we had a good comment yesterday by Shubham Baranwal. And you mentioned, because in this day 66 video, I was doing a problem called right side view, which a potential way to solve it is to use a breadth first search. And I was using a breadth first search, but I use the implementation, right? It's pretty much a queue, right? You do a BFS with a queue. So it's something like while queue, right? Dot length does not equal 0, right? And then you would do something like const cur equals q dot shift, right? The problem being that he mentions, right, that technically, right, if you're doing q dot shift, if you're working with the queue, shift means taking an element off the front of the array. If you take an element off the front of an array, right, if you had something like this is considering, right, if the underlying implementation really depends on the underlying implementation. But in this array, right, if you remove this one here, or we change it to a 0, right, in a static array, what would actually happen, right, is that you would remove this element, right, and all the elements would now be shifted down to accommodate for that. What you actually end up with is either an empty slot on the end, right, if your array is static and it can't change size. If your array is dynamic, yeah, then it really depends on the implementation. Either way, I think in JavaScript, right, shift, worst case, is linear time, because I think you actually it does do the shifting, right? So technically, in that video, I said the algorithm's runtime was linear time, but technically it would be n squared, because shift, worst case, takes linear time. So if that's the case, that was really good. That being the case, that was a really good comment, since I ended up doing some research. And I also realized now that JavaScript doesn't have a native representation of a deck, right? And a deck is just basically a queue that lets you do constant time removal at the end or the front, right? So at either end, right? Insertion. So I'm thinking the underlying implementation is a doubly linked list, or maybe just a linked list. So JavaScript doesn't have a native implementation of that. So yeah, that was just a really good comment. That being said, I was doing flattened 2D vector last night, and I pretty much just did it as a regular LeetCode problem. But I was just reading to the first part of the solution, and it mentions that if we're going to be designing an iterator, right, what we do is literally copy for the constructor, the iterator. We just copy the value into an internal representation under the hood, right, and then next and has next pretty much don't do anything at all. They just pretty much do some benign operations. But in the solution, or the first part of the solution, which basically mentions that this is not a valid solution, is that the real solution, right, is understanding what an iterator actually does. And an iterator is something you can use to iterate over a data set most of the time that you can't fit in memory. The fact that our constructor takes in a vector and then copies it, it's kind of an antithesis to the point of the question, I think. So I'm going to try a different version of this, which we were doing before, where we will just copy it, or we'll just keep a reference to it, and then we'll change our implementation. So we'll do that. We don't have any cards to do, so we'll just do some random weighted cards. And then, yes, I think we also had W comment, as always, from Thomas Wong, right? He says, seeing the weekly contest ranking go up is extremely encouraging. From one of the 4 questions to one easy, to one medium, one easy, and 2 mediums. Give us time, we will climb. This is true. I said, you have a way with words, brother. We're coming. The entire Discord is coming. Also, don't forget to join the hyperbolic coding chamber. There are thousands of people joining every day, so you're going to want to join right now before it's too late. So today we're going to do 30 minutes, and then I'm thinking on Wednesday or Thursday, we'll be back to the usual our schedule with the reading as well. I was also reading about I was reading about some system design earlier today with Netflix, and Netflix is doing some pretty cool things. I was reading about their Reno, which is like their rapid event notification service or something like that. And it was pretty cool because it's interesting to see. I guess I thought it might be more complicated to set up a notification service, but it was a really good read. I'm going to post the engineering essay in the Discord. So you're going to want to check that out for some easy system design tips and tricks from the top programmers. So I'm just going to jump into it. So for flatten 2D vector, right, like we said earlier, we don't want to copy the data into memory because ideally we just like to have a reference to it, right? When using iterator in C++, you can just create the iterator with the source data structure and you can iterate through it, right? So I think that's what we should be aiming for. So we should just be keeping a reference, I believe. So we'll say this dot vector equals vec, right? So how could we make sure that we can still do next and has next? Right, since it's a vector, right, and the number of columns in each row is not predetermined, right, how do we know? And we definitely don't want to offload anything to the front with the constructor. So next, with next, we basically want to return the next element from the 2D vector. Right, and with has next, we want to basically know that there are still some elements left in the vector. So if that's the case, the real thing I think that's just a slight bit difficult is the drop down. The drop down logic, because if we take a look here, right, if the array was already flattened, it wouldn't be difficult, right? We could just have a pointer saying whether or not the data structure is empty. The problem is with the drop down functionality. So if we have a pointer, right, starts at 0, we get one element, we increment it, right? Then we go to 2, right? But the thing is we need to drop down, right, to this row, right, the column below it. So one, that's why I went with flattening the 2D array. So I think what we could do is for next, right, we could just change it so that we keep track. In a way, we could just visualize this as a selection of the matrix, or a selection of the subset of the matrix, right, where we have this box, right, that starts at 1, right, 2, once it reaches the end, drops down to 3, 4, right? And if we do that, what if we keep an internal representation, right, where we keep something like row, which is equal to 0 to start, and column, which is equal to 0 to start, and then whenever we do next, right, if column is less than the current column, the column, right, is less than the length of the column, then we'll just increment it, right? So we'll do 1, so then we'll be at 2, right, and 1 is still less than the column, so increment it, right? Now if it's not less than, right, then we want to reset C equal to 0 and set R, increment it, right? And I think with this we should be able to get to the end. Now the case, right, where we say has next, right, if we say has next, all you have to do is check that we're not in the last row, right, with the last element. And if we're not, then we should still have next. So I think that should work. So we can say R, right, is equal to 0. And we'll say R, C is equal to 0. We don't have to actually include anything there, right? And when we say next, we're just going to say if and we actually might want to use our has next functionality first. We'll say if this dot R is less than, because in that example, right, we'll have 3 rows, right, and the last row being 2, this dot r is less than vec.length, and this dot column is less than, I said vec, this dot vec sub this dot r dot length. That's the case, and it does have next. So we'll say if this dot, well, they said next will always be called on a valid. Next element moves the pointer one step forward. You may assume that all the calls to next are valid. So if that's the case, we should be fine there. All the calls to next would be valid. So all the calls are valid. So then we have next, right? And now I'm thinking, when do we want to increment, right? If we start at 0, 0, right? If we have next, right, then we want to increment our values, but then return the one that's smaller. I mean, increment our particular, right, either the row or the column, right? This is the first thing we need to check. When we start, let's get our matrix back. We start it like this, right? We're at 0 and 0, right? What do we want to return? We want to return basically this dot vector sub r sub c. The drop down is confusing, so I think what we should do, right, is we'll say our result is equal to, I'm getting lost in the sauce. If there's a couple cases, right, when we first start, right, we can just return sub 0 sub 0. Now when we get to 2, right, if we increment, when we get to here with 2, right, we can just return it, right? But at some point, next is going to be in this part right here, which is basically undefined. Now if it's undefined, basically want to set c equal to 0 and 3 and increment the row. And then if we do that, we still want to increment it by 1. So if we have 3 cases, right, the first one being return r plus c as is. First case is 1 and 2 here, right? We just want to return 0. The case is the bridge. Another case is the bridge. So the first case is the regular case. Second one is dropping down. There's 2 cases, right? In the case of the regular, right, how do we know that we're regular? It means that we're not out of bounds. So all we have to check, right, is if our current column is less than the length of the current row. And if we're good, then we can, so if we start with 0, right, 0 is less than 2, so we can just return 0. Otherwise, we won't. Now, if that's not the case, so we're out of bounds here, then we're going to want to fix that value, right, by dropping down. And then we can just return this value. So I think what we need to simplify this is an increment function, which can just be void. And so we can just return we can just have a couple of methods, right? We'll have an increment and we'll have is index valid, which will return a Boolean. Now the way we know if the index is valid, right, is if this, right, is like we said with, I keep deleting this, like we said with the original group, right, that the current column we're at is less than the length of the total row, right? So if we're at column equals 0, right, 0 is less than the length of all possible columns, which is 2. So we'll say if this dot c is less than this dot vec sub this dot r dot length, all right, and we'll check if the index is valid. And then this should simplify next, right? Is if the index is valid, right, then we want to return it, or we want to save the number we're going to return and then increment it and then return it. Right, so we can say if this dot index is valid, right, we'll say const res is equal to this dot vec sub this dot r sub this dot c, right, I'm going to say this dot c plus, and this is the value we actually want to return, so we can return res. Then we also want to do this dot increment, right, because we're going to go next afterwards. Right now, if the index isn't valid, right, then we'll say while index right, then we're going to say this dot increment, then afterwards we can just return basically have these same two lines here, right, where we want to keep, we have a new value that's finally valid, right, from incrementing. Now that's finally valid, you want to return it, but we just have to increment it once more. This dot increment. So how would increment work? So I think there's a couple cases, right? If this dot c is greater than or equal to this dot vex, this dot r dot length, right? So let's say this dot c is equal to 2, right? 2 is greater than or equal to the length of the current row, right? So what we want to do is set this dot c equal to 0, and then this dot r plus equal 1. Otherwise, right, we can just do this dot c plus equal 1. So in the case where this dot c is less than this value, then we'll just do this dot c plus 1. Let's test it, right? If we had 1, 2, 3, and 4, right? we'd say next, right? What would happen is 0, 0 valid. It is, so the result we return would actually be 1, then we increment, right? Is C less than? Is C greater than or equal to 2? No, so we just take it to 1, right? We just return, well, this is the problem, right? It's fine because we already saved the result. So we return 1, 2. Or now, if we do it here, now be at next, right? So we'd say, is the current, after 2, we'd say, is the current index valid? Well, this dot C is 2. Is 2 less than, right, this dot R, which is 0 dot length 2 is now less than 2. So we're going to do else. While the index isn't valid, right, we're going to increment. So what would we increment? We'll say this dot C is greater than or equal to 2. So we're going to set this dot C equal to 0, increment R. So I think this could work. I called it vec. Index is valid. So definitely getting the values in the correct way, but has next is not giving us what we want. So we're saying if this dot R is less than this dot vec dot length and this dot C there's also a possibility I'm realizing for this to run forever. So we'll say this dot R is less than this dot vec, so it doesn't run forever. I think this actually, if this dot R is less than this dot vec dot length, this dot C is less than, and I don't think we want to do, I want it to be less than the last element in the array. So dot vec. If we print this dot R, this dot C, so this dot vec dot length, right? And for C we print this dot vec, so this dot vec length minus 1. So I think what we don't want actually is and, right? Because if one is less, if the current row we're at is less than the current vector, then they're still left. And if they're the same, then we want to make sure that C is less than the vector length. I think what we want actually is or. And I think this might get us what we're looking for. So yeah, 1, 2, 3, true, true, and then we pull out 4, which is the last element. But then we actually, when we has next, we still have false. We return true, they're looking for false. All right, so why is that? Right, so the last row is going to be 0, 1, 2. Is 2 less than this dot vec dot length. And I see why it's saying true. I think we want we want a stricter check. R plus 1 is less than or equal to this dot vec dot length. Right, so when we have 0, we're in index row 0, we're still less than it, right? 1, we're still less than it. 2, we're still less than it. The problem is if we use or, it works for rows 0, 1, and 2, but then when we have a very specific value, like checking if 4, right? If our pointer is moved all the way up to where 4 is, we have a problem because R plus 1 or that is going to give us an issue. So we have 4. Basically right here, right? R is going to be equal to 2 and C is going to be equal to 0. If we copy this down to has next, right? You can see that this to R plus 1, which is 3, 3 is less than or equal to 3, so we're going to return true, which is the problem. Change this to and, right? It's 2 less than or equal to, is 3 less than or equal to 3? Yes. Okay, now is 0 less than last element, the last row in the length of the last matrix, right? 0 is less than 1. So maybe that does work. The problem being the case, right, when we have 0 appear, 1 is less than or equal to 3, right? Then we do and, right? And then we're going to say 2 is not less than So I think what we're seeing is we just need more cases. We break it into two sets of cases. Everything before the last row and then the last row. If it's everything before the last row, then as long as the current row is less than where we are, or right, if the row isn't the same, there's two cases. If the row is the same as the current row that we're at is not the same as last row, then we know that the element still exists. So we know that we don't really have to check what column we're at because we know elements still exist. So if this dot r plus 1 is less than or equal to this dot vec, then we can just return true, right? And I think we can compress this in a second. And then we'll say, or this dot r plus 1 equals this dot vec dot length, right? So now it equals the length. And this dot c is less than this dot vec, so this dot vec dot length minus 1. Right, otherwise we'd like to return false. So we're returning true, we're returning false, false, and false, where we have to return two more trues. Oh, I suppose this supposed to be less than. I don't know why that said greater than. All right, and we're in the last row, right? Is equal to vec length, and this dot c is less than the length. So if we do has next, right, we get true. If we do next, right, we get 1. If we do next, is the index valid? It is, so we return 0, 0, then we should increment. Right, and it'll say this dot c, right, is greater than 0 is not greater than 0, so we should do this dot c plus equals 1. So then r should be equal to 0 and c should be equal to 1. And we do has next, if this dot r plus 1 less than this dot, so is 1 less than 1, notice 1 equal 1, yes, and this dot c, which is 1 less than the last element in is it less than the last element in the matrix? Oh, there can still be empty elements in the matrix. So I think we can fix this with just index is valid. Right, we can just make sure that, yeah, this is a valid location in the array, and this dot vec, this dot r, so this dot c actually exists. So row sub 1 sub 0. So if we run this, I think it should still be true, but if we change it to this case, sub this dot c so 0, 0 is 1. I guess what I'm confused about is the current index is, I think I see what's wrong. It's this next function. The index is valid. If we say the index is valid, then we want to get the current value, increment, and then return it. Problem is, we don't actually know the next index is actually valid. So I think we want this. We could just have a function that says next valid index is void, and it just does this right here. So while the index is invalid, it just finds the next non-valid index. Also, we don't need increment. And then what we'll do is, if the index is invalid, we'll do res, right? We'll just say this dot next valid index. And if it's invalid, we'll say this dot next valid index. You give next valid index afterwards, then we'll return the result. This is getting very messy. See has next true. We get the next value 1, then we say has next. Now understanding this dot r is less than this dot vec dot length. So if we just map it out, we have has next, or we have a matrix with 2 rows in it. We say has next. We call has next is 1, right? R is 0. 0 plus 1 is 1. It's 1 less than 2. Yes. All right, so we return true. Then we say next. When we call next, we say is the index valid? Well, is the index valid? What did we print for the console? 0, 0, 1. All right, so we return that index. If the index is valid, we return the current index. I think I complicated this. Say next valid index, then we just return the result. So I think what they're saying is after we do next, right, the pointer should be sitting at line 37. Oh, so this is, and it's empty. I guess we should safely navigate. Right? Yeah, there's just a lot of assumptions we made. So we're getting undefined. I think that's because our is valid index is valid, right? We say this dot r sub this dot c. And we'll just say it's greater than or equal to 0. Or we really want to know is that it's a number. Let me check something. So I think what we can use is the is non function. So say that the value here must be a number. He has next. So what's happening here, right? We know that the elements still exist, but we need to know that the elements that still exist are actually valid. I think what we want I wonder if we remove turn into spaghetti code. We want something that returns pretty much whether or not hasnext is still useful. We do, or it's currently happening, is that we do hasnext. This is just a mess. We do hasnext. There are technically still elements remaining, but they're not valid. think what we can do is just, with what we have, we create a temporary temp R, which we set to list.r, and a temp C. This.r and C, and then we'll say has. Maybe we can create a loop, and this loop will pretty much check the next valid value. The problem is all the current functions are stateful, but now we want a stateless version, and it just doesn't exist. We could maybe solve this if we turn next valid index into an array of tuples. So if we turn it stateless, right, we could say R and C. And then we could turn increment stateless as well. We could take R, which is a number, C, which is a number, and return a tuple of numbers. And say this dot C, just say C. This dot R will just say R. And then we can return R and C. Then we can do new R, new row, and new column is equal to this dot increment, right, by passing in R and C. Then we can do is just say this dot R is equal to new R, and this dot C is equal to new C. Or call this temp R, temp C. We call this new R and new C. We pass into these functions will actually be temp R, temp C. Then new R, returns a tuple of new R and new C. This reminds me of LRU cache. So this dot R equals new R. This dot C equals new C. This is a mess. Yeah, this is dead. And yeah, we just need a better approach.